to see a problem on DLS, that is development of lateral surface for a square pyramid. Here is the question. A square pyramid, side of base 40 mm and axis length 60 mm, has one of its triangular face on HP with axis parallel to VP. It is cut by a cutting plane passing through the center of gravity of a solid and inclined at 30 degrees to VP, removing the apex. Draw sectional elevation, plan true shape of the section and DLS of the pyramid. So this is the question in front of us. Here various conditions are given. First, by reading the question we understood that the type of solid is a square pyramid. So I'll explain the diagram of a square pyramid, and after that I'll be explaining the remaining conditions step by step. So let us get started. So here is the diagram of a square pyramid in which the base is in the shape of a square base. Then this is the axis of the square prism. Then these are the slant edges, and since it is a square pyramid having 4 edges at the base, so and at the same time there are 4 corners connected to a common apex forming the triangular faces. So this is a square pyramid. Now in the question it is given that square pyramid, side of base 40 mm, axis length 60 mm, has one of its triangular face on HP. It means this pyramid will be tilted. It will be tilted in such a way that now it is resting on the base, but if we tilt it, it should rest on this triangular face on HP. So let us get started with the initial conditions. Here I am drawing a light horizontal line first. Next, since the square pyramid has to be tilted on its triangular face, here I am drawing the square in HP because we have this as VP, vertical plane, and here HP. When the triangular face on which it is resting, it should be in HP. It means the complete square pyramid is in HP. So when we are looking from top, we should see the square of side given as 40 mm. I am drawing a light horizontal line, measuring 40 mm over it. Then light vertical lines through it. Connecting the corners to get the diagonals. So this is the square pyramid as we look from the top. Here I'll give the notations. Now I had used this condition because only in this condition we can tilt the pyramid in such a way so that it will rest on the triangular face as mentioned in the question, and that triangular face is O34. So this is the top view of the square pyramid. Now I'll project the front view. From the front we are going to see the triangular face of the pyramid. Height of the pyramid given is 60 mm. So I'll mark 60 over this. Giving the notations. Here we have apex O dash, point 1 dash, 2 dash. Then we have 3 dash, 4 dash. Now we have to tilt this pyramid in such a way that it should lie on the triangular face. What is that triangular face? It is O34. In the front view it appears as a line O dash, 3 dash, 4 dash. I'll make this line coinciding with this XY line. selecting a point here, measuring the distance from 3 dash 4 dash up to O dash. So here we have, this will be point O dash, and here this is 3 dash comma 4 dash. So here I have tilted this pyramid about the triangular face. Keeping the same distance, I'll draw a light arc, then measuring the distance of the base, keeping it on 3 dash 4 dash and cutting this arc with the help of light line. Now I'll join all the points. So we have 1 dash and 2 dash. Now here I have tilted this pyramid and I'll mark the axis as well from 3 dash 4 dash to the center. Light line which indicates the axis. Now when this pyramid is tilted, here we have got the front view of that. Next I will be plotting the top view. For that, observer is there at the top. When we are looking at top, those points needs to be projected first which are visible. So this complete base is visible to the observer. Plotting the points. For 1 dash 2 dash, here we have 1 and 2. So point 1 and 1 where they intersect, we are getting point 1. Then 2 and 2, this is point 2. 3 and 4, so here we have point 3 and this will be point 4. Then for the apex, I'll draw a light line. So O and O dash where they intersect, that will give us the apex point O. Joining all the points in proper sequence, entire base is visible. So 1 2 O will be connected, that is closer to observer, so visible. O to 2 is also visible, so connected. Then O to 4, that is going behind the observer, so it will be hidden. So drawing it with the help of dotted line. I am not making anything dark here. First we have to keep it light. Next O to 3 is connected. So now this is the top view of the pyramid and it can be seen that it is resting on the triangular face O34 as mentioned in the question. Now after this we have to locate the cutting plane. For that the condition is given. Here it is said, it is cut by a cutting plane passing through the CG, center of gravity of the solid. Since we have a pyramid, its CG is h by 4 distance, that is, it is 1/4 of the total height for the pyramid from the base. So if we take the total height, it is 60 mm. So 15 mm from the bottom, which is h by 4 distance, that is the location of CG. So this is the CG for the square pyramid. Now this CG of the square pyramid, I locate it in the second condition as well. So from the base, I am measuring the distance up to point G. So from the base up to point G, here I am getting the center of gravity of the square pyramid. Next, this center of gravity will be projected in the top view. For that, we require a light vertical line. And here we are getting the CG as point G in the top view. Now I'll read the condition. Once the CG is located and inclined at 30 degree to VP, it means the cutting plane is passing through the CG, center of gravity. Inclined at 30 degree to VP, it will be seen in HP. Removing the apex, it means we have to adjust the cutting plane in such a way that apex is removed. So if I am measuring 30°, then instead of taking 30° from the left, because if I take from the left, in that case the cutting plane will be passing in such a way that apex is retained, but here in the question they have mentioned that apex should be removed, so I have to take 30° from the other side, removing the apex. So I am measuring 30°. With VP it is seen in HP, and now we can see that the apex will be removed. Drawing a light line. This light line shows the cutting plane, and as an observer we are here, so the portion which is close to the observer should be removed while taking the section. So this apex portion will be removed, also it is mentioned. So here I'll make the cutting plane dark first. Cutting plane A dash. Now I have to remove the apex as mentioned and retain the portion in which there is no apex, so the portion which is behind the cutting plane will be made dark. So I'll join all the points here. So here is the cut section of the pyramid. Only this much part is retained. Once I have drawn it dark, I can make the initial conditions also dark. So here I am making the initial conditions dark. Next, I have to locate the points where the cutting plane is in contact with the pyramid in the top view. So here, where it is cutting O to 1, that is the slant edge, I'll call that point as A. This is A, and A I'll project it into the front view now. Projecting point A. In the front view, this will be point A dash. Then, where it is cutting O to 4, I'll call that point as B, and projecting it on O dash 4 dash in the front view. Here we have point B dash. Next, after locating B dash, edge 1 to 2 is also cut. This is the base edge which is cut by the cutting plane. I'll say it is point C. So when we project it, point C is directly coming onto this location, which is 1 dash 2 dash. So this is point C dash. Next, cutting plane is cutting edge 3 4 also at the location. I'll say that is point D. So if I project it, it will also be on this location as 3 dash 4 dash. So that will give me the point D dash. Now joining all these points in the proper sequence, A dash B dash, A dash to C dash, B to D, and D to C. So in the question it was mentioned to draw the sectional front view. Now this much part of the pyramid is remaining, inside which we have to draw section lines inclined at 45°. So this is the sectional elevation, also called as sectional front view. Apex has been removed, so this portion should be kept light. This much part of the pyramid is seen. Then we have to draw the true shape of the section as well as the development. For true shape, we have to make this cutting plane parallel. First, I'll be drawing the true shape of the section. For that, I need to draw a light horizontal line. Light horizontal line. Then, measuring the length of the cutting plane. Cutting plane is in contact between points D and A. So measuring this distance. So here we have point D and this is point A. Next we need to plot the other points up to B, point B, then C, so measuring from D to C. Now for the true shape, first I'll be projecting point A upwards with a light line. Then here we have A dash. So projecting it light where they intersect, that will give me point, I'll say this is A double dash. Next for point B, here we have B dash on XY line itself, so this point is B double dash. Then point C, C dash has been projected with light line, light horizontal line, where they will intersect, that will give me the point C double dash. At last D dash, for that point D will be projected up, where D and D dash they intersect, that will give me the point D double dash. Joining these points in sequence will give me the true shape of the section. A double dash, B double dash joined, then B to D, A to C will be joined, and C to D. Next, for the cutting plane, I'll make it dark. Cutting plane A dash. Then I need to draw section lines over this true shape. So this is the true shape of the section. Then we have to even draw DLS, it is mentioned that draws sectional elevation, which is the sectional front view we have drawn, plan, top view, true shape of the section done, and last is and DLS of the pyramid. So we have to draw the development of lateral surface for this pyramid which has been cut. And for that purpose, the first step would be to get the true length, because here we are going to open this pyramid and I am going to open it about edge 1 to 2. This pyramid will be open. So here I have O dash 1 dash, but in this case we require the true length. And how to get that true length? Drawing a light horizontal line, then measuring the distance from point O up to point 4, and then drawing a light arc here. This method needs to be followed if we want the true length of the slant edge. So projecting this point vertically upwards and joining it to the apex. Now this is the true length of the edge or the slant edge. Either we can say slant edge O dash 1 dash or O dash 4 dash, O dash 3 dash or O dash 2 dash. Now for this I need to project this slant edge here as well. So here I am extending the base slightly with the help of a light line, and then I can take the distance either from 3 dash 4 dash, or I can say the slant edge will remain same. So if I measure this slant edge, the true length, I can cut this line in order to get the true length of the slant edge. So this is the point, and here we get the true length of the slant edge. Now we have to take this true length as a reference to get the development. So I'll be measuring this radius and then drawing a light arc. Now here I'll say that this is apex O dash, and the edge about which I'm opening, that will be O dash. I'll say it is 1 double dash. Then measuring the base edge and dividing this arc into 4 parts. One double dash, two double dash, three, four, and again one. Joining all these points to the apex, which is a common vertex. Then, since it is a pyramid, the base edges will be sharp. Next, I need to transfer the points. See, A dash is on O dash 1 dash, as I have explained, on O to 1. So that will be transferred. So I'll take the distance from the base edge, transfer this point A parallel to it onto the true length, and then here I'll be getting the point A double dash, and then keeping the same radius, I'll mark on O double dash 1 double dash. That will also give me the point A double dash. So there are 2 points of A double dash, one at this location, other at this location. Next, for B dash, now B dash will also be transferred first onto the true length, and then B is on O to 4. So on O to 4 it will be transferred. This should be parallel to the base edge. It should be parallel to the base edge. Similarly, B also should be parallel to the base edge. So I'll get another point A, which is actually A will be at this location. Similarly, B will be transferred from here onto O to 4. So this will give me B double dash, and A double dash is at this location. This is A double dash. Here I'll change the point, that should be parallel to the base. So this is the new point A double dash. Then C is on the base edge 1 to 2. So we have to directly measure the distance from 1 to point C and mark it towards 2. So 1 to C, marking it towards 2. That will give me the point C double dash. For D, it is from 4 to D towards point 3. Towards point 3, giving me D double dash. Next, we need to join the points in proper sequence so that we get the development. So A will be connected to B. Then after that, B, C and D are connected. B to D will be connected. Then I'll make it dark. Next, O to this apex point 2, 3, all are removed. So this portion won't be made dark, it will remain light. So this is the development of lateral surface for this cut pyramid. Then I'll be giving the dimensions. Base edge was of 40 mm side, height of 60 mm of the pyramid. This is the location of center of gravity at 15 mm from the base, and the inclination of the cutting plane was given, inclined at 30 degree. to VP seen in HP. And this is the true shape of the section. Here I'll draw the axis. And with this, we complete the problem.